Hello everyone, let's talk about another medium problem on Leetcode today. Find the winner of the circular game, also known as Josephus circle, Leetcode 1823. The problem says that there are n friends that are playing a game. The friends are sitting in a circle and are numbered from 1 to n in the clockwise order. More formally, moving clockwise from ith friend brings you to I plus 1th friend, where I is greater than equal to 1 and less than n. And moving clockwise from nth friend brings you to the first friend. And the rules of the games are as follows. Start at the first friend, count the next k friends in the clockwise direction, including the friend you started at. The counting wraps around the circle and may count some friends more than once. The last friend you counted leaves the circle and loses the game. If there are still more than one friends in a circle, go back to step 2, starting from the friend immediately clockwise of the friend who just lost and repeat the game. Else, last friend in the circle wins. Given the number of friends n and an integer k, return the winner of the game. So let's look at the example. For n equal to 5 and k equal to 2, we can see that there are 5 friends sitting in the circle. So we start from the first friend from here and then we count k times. So we can see this is k equal to 1, then k equal to 2. So as soon as we see the second friend, we just eliminate it from the list. And now we start from 3, the next clockwise friend of 2 who was eliminated. Then we eliminate 4. Now we start from 5 and eliminate 1, right? Similarly, now we start from 3. So we eliminate 5. And now only 3 is remaining. So that is our answer. Now, in terms of solution, there are multiple ways to solve this problem. So one way can be that we use the array list and store all the friends in it and follow the simulation. And to get the circular linked list, we can actually use the modulo operator on the list size. Let's see how. So initially the list will contain all the 5 friends in it. So it will be 1, 2, 3, 4, 5. Of course, the list in Java is 0 index. And initially our friend that we want to start with is at 0th index. So we will start from it. And now k is equal to 2. So we will just count k elements. So what will be our next element? It will be current index plus k minus 1. And the reason for this is when we are counting, we have to also include the element we are starting from. But this is a straight list, not like a circular list. So to overcome this, we actually use the modulo operator on the size of the list. In this case, it's 5. So we have to eliminate 0 plus 1, which is first index. So we will remove 2 from the list. Now our list becomes 1, 3, 4, 5, and our index will become 1. So now we start from 3. Now we will continue with remaining list. So our list is 1, 3, 4, 5 and current is equal to 1. So now we try to eliminate the second element. Again, following the same formula, we will be just using current plus k minus 1 percent m, where m is the length of the list. So it will become 1 plus 1 percent 4, 2, right? So we will eliminate element at the second index, which is 4 in this case. So we now go to the next element in the list. So our current is now equal to 2, right? So it will be at 5. And now our list becomes 1, 3, 5. Now we eliminate next element from the list, which is equal to 2 plus 1 modulo 3, which is 0. So we eliminate 1 from the list. Now our list has 2 elements, 3 and 5. And our current was at 0 because we just eliminated 1. Now we eliminate next element from the list using this formula again. Now we start from 0. So 0 plus 1 modulo 2 is equal to 1. So we will eliminate 5. And now our list has only one element, which is 3. So we will just return 3 as an answer. In terms of time complexity, it is O of n square. And the reason for this is like we are running the simulations n minus 1 times because the list has n elements and we are removing n minus 1 elements from it so that only one element remains. And on top of that, removing the element from the list takes O of n time, whether you take array list or linked list. So overall, the time complexity is O of n minus 1 into n, and that is O of n square. But can we do better? And the answer is yes. And the reason for this is like if we look at our previous solution, the biggest drawback was removing the element from the list, which takes O of n time. So instead of that, how about we use a queue? We can use a queue to represent the friends sitting in the circle. Now we have to start the game such that we eliminate n minus 1 friends from the queue and we stop the game when only one friend remains in the queue. So each time we start from a friend, then we count k friends from there. We send k minus 1 friends at the end of the queue, but we eliminate the kth friend. That is, we don't ask this friend to actually join the queue. So if we continue this way, we only have one friend remaining and that will be our answer. Now let's see this in action. Let's take n equal to 5 and k equal to 2. So initially we will enqueue all the 5 friends. So it will be 1, 2, 3, 4, 5. And now we start from the first friend. So we take out k friends out of the list. So that is 1 and 2 and enqueue back 1. But we don't send the kth element, that is 2, back to the queue. And now our queue becomes 3, 4, 5, 1. Now at the front of the queue is 3. So we will start counting k elements from it. So it will be 3 and 4, but we only enqueue back 3. So our queue becomes 5, 1, 3. So now 5 is at the front. So we dequeue 5, 1, but we only enqueue back 5. So now our queue becomes 3, 5. Now 3 is at the front of the queue. So we dequeue both 3 and 5, but enqueue back 3. And now 5 is eliminated and we have only 3 remaining in the queue. Now as we only have 1 friend remaining, 3 is the winner. Now that we have seen the example, let's jump into the code part. Now we create the queue to store the friends in it. In Java, we can use linked list implementation. We start adding n friends to it. Let's call it friends instead of queue. So friends.add I to it. Now we will play our game. We run the loop n-1 time to eliminate n-1 friends. And now we run the nested loop k-1 times to add back the friends after pulling them. And once we do that k-1 time, the k-add time, we will remove the friend that has to be eliminated. And in the end, we have only 1 friend remaining. So we will just return it. So we will just say friends.poll. Let's run this code. There's a typo, an integer. So let's run it again. Awesome. Let's submit this code. Cool. In terms of time complexity, it is O of n into k, right? Because it takes O of n to add the friends, and then we are playing the game n-1 into k times. And in terms of space complexity, it is O of n because we are storing n friends initially in the queue, and that will be our space complexity. And now the question is, can we do better? And the answer is yes. There is a mathematical solution which actually reduces the time complexity to O of n and space complexity to O of 1. But during that interview hour, this kind of a solution may or may not come to our mind. So I think better stick to the solutions which actually showcases your programming strength, like data structures and algorithms. But if you are interested in reading this mathematical solution, please do read it on my blog. The link is in the description below. So I hope this video was helpful to you. If it was, please like and subscribe. Have a nice day. Thank you.